Hi guys, this is Alafia here, and today I will demonstrate a demo for MicroAI ESP32 Security SDK. Before we dive further into it, there are a few things I would like to go over that might help you understand MicroAI better. So what is MicroAI? MicroAI is an AI engine that can operate on low power and endpoint devices. It can ingest sensor as well as computational data and use it to detect abnormalities and life cycle of entities. And thus, this input can then be used in multiple applications as you would like to. Uh, we have two use cases supported by MicroAI. The first is APM, that is Asset Performance Management, where you can attach external sensors to ESP32 to monitor an activity or an entity. And the second use case is the security use case, which will be covered in this video, where we use internal monitoring on the device to predict abnormalities in its usage, which are consistent with security breaches and vulnerabilities. So before you can try your hands on this demo, if you haven't downloaded the MicroAI ESP32 Security SDK, I would go ahead, stop this video, download that, and then you can continue with me from here on. So once you've downloaded the security SDK, the directory structure would look something like this. Where we have the README file, the MicroAI ESP32 SDK documentation, the main file, the documentation file, and the components file. So go through the README. It will give you a brief idea about what are the library files that we have, how you can configure the project, how you can build and flash and monitor your program, and how you can also customize it. Also go through the MicroAI ESP32 documentation. It will walk you through how you need to set up your MicroAI, what are the things that you need, and how you can also customize your program in much more detail. The main file consists of the ESP32AI.c file and the ESP32AI.h file, which will be the library you need to integrate ESP32AI.c, which houses the majority of the code, that is the X code, the Y code, and the AI engine code, and all the action is happening up here. We also provide the MQTT.c and the MQTT.h file. These support MQTT communication, so you can use your output data from your AI engine to send to any application via MQTT. In this demo, we will be using an in-house product called C2M, where we will be using MQTT to send data to C2M and see our results there. In the documentation folder, you will find the SD card files. That is the files you need to load on your SD card. That is the alk-bar file, which has parameters for every channel, and you can customize and set it according to your needs. The CFG file, which is again parameters that are required to train your model. And the CFG explain file, which gives you a better brief description about what the CFG parameters are. And then in the components, we have the AI engine and the security channel folders. This code is hidden for confidential reasons, but the AI engine basically houses the MicroAI engine code. and the security channels houses the internal monitoring or the computational data that is captured to predict abnormal behavior by the MicroAI SD card. So now that we know a brief description about all of what is contained in the SD card, what you will need to run the MicroAI ESP32 security use case is an ESP32 development board. We recommend the ESP-WROVER-KIT with a SD card for storing your model once it's trained. You will also need a USB cable for power and communication to your board, and the output is sent to a monitor screen. So you will need that too. And you also have the option of sending your output code to various applications via the MQTT. So ESP32 Security SDK has two modes. One, which is the model training mode, and two, which is the normal modes. For model training mode, you will put your SD card reader into your computer, and in the CFG file, set the first parameter to 1. This, and after this, when you save and you put your SD card onto your ESP32 and run the program, it will train your model. That is the training mode. The normal mode is when you set this parameter to 0, save it, and load your SD card into the ESP32 device, and again load and run your program. This will enable to run your ESP32 in the normal mode, where you can then predict abnormalities and security attacks. For a brief code walkthrough, this is what we call the Xcode, where we predefine the structure of the security channels and the structure of the AI channels and assign the security channels to AI channels, which then in turn is fed to the MicroAI engine, and the MicroAI engine then uses this code to predict the abnormal behavior. And the Y code determines what to do with the results. In this case, we will be displaying it on a command line, as well as we will be sending it to C2M. So now that we know how to work with MicroAI security, I've already pre-trained my model for 180 seconds, and I have loaded my SD card into normal mode, and I will be showing you how you can use it to perform attacks and predict abnormal behavior. You can use any one of the commands, that is just idf.py, idf.py, and then build flash and monitor. If you also want to save your build, you can use this command, provided a location to save your model, and you can build. So build will build the model, flash will load the model onto your device, and monitor will display the results on a screen. This will take a while. While this is running, once this starts running, we will use the MicroAI attack tool on the Raspberry Pi. So if you do not have that, go ahead, stop this video, see one of the videos for MicroAI on Raspberry Pi, and I will show you how you can use the attack tool from a Raspberry Pi to attack ESP32. So now that your ESP32 is already working and sending data via MQTT, I will go ahead and log into my Raspberry Pi where I already have the MicroAI loaded, and I will navigate to the MicroAI SDK folder on my Raspberry Pi, then the security subfolder, and then into the attack tool. Then I will move to the Initiator subdirectory. Now to run the Initiator script, you need to run it in sudo mode. Here is the Initiator script. You need to run it in sudo mode, and you also need to use Python 3. So you can check your Python 3 path using which python.3, and then use command sudo -e, the path to your Python 3, and then the Initiator script. Sorry. Okay, and let's start it. In another Raspberry Pi command window, I will do the same, but this time I will navigate to the command center folder in security attack tool, and I will again run this using Python 3 command. Once you've done that, you can perform any network layer attack on your ESP32 device. So run a man in the middle attack. Go back and see that an alarm is generated here. And like I said, I will be sending data to our in-house product C2M via MQTT. You can see that an alarm has also been generated here. And you can see the data is coming live in here. Once the attack is performed, it will display a message like this, where it says the target I, and then you can try another denial of service attack. Where you see alarms being generated again. I can see these alarms being generated here too. So this was the demo for ESP32 security. If you have any more questions, do visit our OneTech site, our OneTech developer site, download the SDK, goof around, have some fun. We also support the same product on Raspberry Pi. Please go ahead and check it out. And if you have any questions, go to our FAQ page or contact us, and happy coding.